centered at a equals 2. Okay. So step 1 is find that nth derivative formula. Somehow, some way. Okay. All right, so my function is e to the 2x. First derivative is, what is first derivative? What's the derivative of e to 2x? Chain rule? 2e to the 2x, okay? Yeah, 2e to the 2x. Because the derivative of e to the power is just e to the power. Where's the 2 come from? The derivative of 2x, right? With me? Second derivative. Second derivative, well, I've got 2, and then the derivative of e to the 2x, and that's 2e to the 2x, or 4e to the 2x. All right, third derivative. It's 4 times, well, the derivative of e to the 2x would be 2e to the 2x again, so that's 8e to the 2x. I can see a pattern here. What's fourth derivative? Fourth derivative would be 8 times the derivative of e to the 2x, which is 2e to the 2x, so that's 16e to the 2x. And fifth derivative, 16 times 2e to the 2x, which is 32e to the 2x. Now let's compute those at a. What's a in this case? I've switched it up on you here. We were doing a equals 1, now we're doing a equals 2. All right, so at a equals 2. So I want to do f of 2. F of 2 would be e to the 2 times 2, which is e to the 4. The first derivative at 2 would be 2e to the 2 times 2, which is 4. 2e to the 4. Ooh, this is pretty good. All right, second derivative. Second derivative is 4e to the 4. Third derivative at 2. Third derivative at 2 would be 8e to the 4. Really, all that's changing is the number in front. Fourth derivative at 2 is 32e to the 4. And the fifth derivative at 2 is... Did I do the fifth derivative? Oh, I see what I did. This is... Fourth derivative is 16e to the 4, and the fifth derivative is 32e to the 4. Okay? Well, what's the nth derivative at 2? Well, one part of it's easy. It's e to the 4. That doesn't change, right? That's kind of a constant for all these. Since I'm valuing it at 2, all these are e to the 4th. So there's no variability at all on that. It's just e to the 4th. The question then becomes, well, what about these? Huh? It's powers of 2, aren't it? Isn't it? This is 2 to the 1st. 2 to the 2nd, 2 to the 3rd, 2 to the 4th, 2 to the 5th. Yep, powers of 2. And it's working really nicely because the fifth derivative of 1 is 2 to the 5th. The fourth derivative is 2 to the 4th. So it's 2 to the n, is that what you said? Does it work for all n? 2 to the 1st, 2 to the 2nd. Does it work for this one? Works for that one too, because this is the 0 term, and that's 2 to the 0, isn't it? Just 1? It's right here. But. All right. Yes. We're good to go. So this is my nth derivative formula at 2, so I can plug that into my Taylor series. Right there. So my f of x is e to the 2x is going to be the Taylor series. This one goes, I can go from n equals 0 to infinity for that one. It works, the formula works for all of them. Okay, so that would be the nth derivative is 2 to the n e to the fourth over n factorial. X minus the a is 2 to the nth. And the nice thing about that, there's no cancellation, is there? No. Other than, I don't know if they would. We could combine, like we did with the -1 to the n. We could. I don't know if they'll do this or not, but we could combine those because they're both the nth power. So that would be what? Power series would be n equals 0 to infinity. That would be e to the fourth n factorial. Let's go ahead and write that. And then this would be times 2, 2x minus 4 to the nth. I don't know if they'd do that or not to you, but they might. See where that? Is everybody okay with that? All right, now, let me look at one thing here. Let's look at the graph of these. Maybe this will work pretty good. Let's graph this. And the first, this one's harder to graph over here because that's infinity sum. It's a series. So let's graph this and then graph the y equals the first 3 terms of that. Let me see if that's going to work pretty good. Just to show you what this is doing. E to the 2x, if I can find, there it is. Let me see if this is going to, should be a good one. Had to bring my other calculator today, so okay. This one might not be the best one. Might have been better for the other ones. What would the first 3 terms over here be? That's the question? Okay. First, all right, so the first term, it starts at 0, so it'd be e to the fourth, 0 factorial, 2x minus 4 to the 0, which is 1. First, n equals 1 would be e to the fourth over 1 factorial, 2x minus 4 to the 1. And then the third term would be n equal 2, so it'd be e to the fourth over 2 factorial, 2x minus 4 squared. Which, yeah, this one simplifies nicely, doesn't it? That's 1. And that would be 1. So it'd just be, and that's 1. So it'd just be e to the fourth plus e to the fourth times 2x minus 4 plus, see, that's 2, isn't it? E to the fourth over 2, 2x minus 4 squared. So really, it's just a polynomial. Not too bad of a polynomial. All right, so let me plug that in and see what happens. E to the fourth plus e to the fourth let's factor that off, times 2x minus 4 plus e to the fourth over 2 times 2x minus 4 squared. 2x minus 4, not 44. Okay. All right. Now let me see what that looks like. Let's see. I need to go. Still not. What is e to the fourth? E to the fourth, that's a very pretty number, isn't it? Somebody got it? What? Come on. There we go. Okay, I see. I'm going to have to get my window up a little bit. Let's go up to 100. Okay. And what we need to do is zoom in right here. This is up here at 54 or so at 2. So I need to zoom in kind of right there. Let me see if I can do that. F2 on mine, zoom in. Okay. All right, so here's what happens. Basically, this is a squared graph, and so, yeah, we get the parabola. But you got the 2 to the x coming in here. That's e to the 2x, sorry. And then this function is coming in here. I'm zooming in here at 2, which is about 50. This is coming in. And right about there, this graph and this graph kind of are looking pretty close. Huh? There. It's centered at 2. This basically x squared function is doing a pretty good job of mimicking around 2. So that's why we say this is centered at 2. Because that's where these two things will be coinciding, and that was just with the first 3 terms. If I go out to infinity,